All right, thank you again, everybody, for joining us today. We're gonna have a great session for you talking about GitOps using GitLab, Terraform, and Terratag. I'm gonna drop the link to our notes document in the chat. Please help us to take notes, and please think of some great questions for our presenter today. Speaking of presenters, we have a special guest as well. So I wanna turn it over to Itzik to do some introductions.
Thank you, John, and good morning and good evening, everyone. And I'm not a special guest. I'm Itzik Baruch. I believe most of you know me. I'm a technical marketing here. Mainly, I focus on the continuous integration. And today, the session is a really great content we have for you about GitOps and the few tools that enable GitOps. One of them is GitLab. The second is Terraform, and another amazing tool called Terratag. That the combination of three of them has a unique offering that can help customers to enable DevOps. So I will not speak a lot, and I will introduce the special guest who is here. His name is Omri Hay, and he is the CTO of a startup that developed the Terratag. That they have kind of integration with GitLab, and this is part of the offering. So I will, Omri, can you elaborate about your solution? And before that, just together we wrote a blog about all of that solution. It's officially in our website. So this is another resource that you can use later on, and also send to customers, because it's a really very detailed and great blog. So Omri, if you're ready. So.
Sure. So thank you guys for having me, and it's a pleasure to be here. I'll start by sharing the screen. I have like a deck, and let me just do that. Everybody can see my screen. All good?
Yeah.
Great. So today we're going to talk about infrastructure as code, and how GitLab and Terratag and Terraform plays into play. So let's get started. The agenda today is a bit of an introduction, a bit about me and the company, and infrastructure as code overview. We mostly around Terraform, but not only around Terraform. The GitLab solution and what it has to offer on the infrastructure as code space, and then how to implement that together with Terratag, which is an open source developed by M0, and a bit about M0 and our solution and how it integrates with GitLab. And then we have like a Q&A session at the end. Cool. So a bit about me. My name is Omri Hay. I'm 38. I'm married, 3 children, love playing tennis, and I'm a soccer for Liverpool, which is a soccer team. So I'm into sports as well. I'm the co-founder and CTO of M0. I have like 15 years of experience managing various R&D teams, mostly around cloud infrastructure. So that's about me. There's a link to the GitHub, Twitter, LinkedIn, and whatnot. And a bit about M0. So M0 is a startup that me and Oad founded almost 2.5 years ago, a bit more. Oad had like a various experience with development in various companies like Microsoft, eToro, and VMware, and others. Basically, we are funded by Microsoft with M12 and Bold Stars, Growth, and Crescendo. Up until now, we raised $24 million, and we're currently around 25 employees, mostly in Israel and some in the Bay Area and in the US. So that's about us. And our mission is to enable DevOps engineer and team to collaborate on automated and provisioning of Terraform, Terragrant, and other infrastructure as code framework. Our solution is basically addressing the problem of provisioning and compliance of infrastructure on cloud resources, and build to scale and basically collaborate within the DevOps team, and also creating a self-service management platform for other teams in the R&D, if it's development, QA, and others. Cool. So that's a bit about me and Zero. And basically, this deck is based on the blog post, like Itzik mentioned. There's a link to the blog post. You're able to read that. And I'll tell you a bit about infrastructure as code in Terraform, and then GitLab, and by the end, Terratag. Basically, Terratag is an open source that we developed in-house for our solution and our platform. We saw that there's a lot of need for that, so we open sourced it. But basically, it's baked into the platform, but you can use it anywhere you want to. So that's a bit about the background of Terratag. And actually, we have a patent on it, so it's kind of cool. So we'll start off by talking a bit about infrastructure as code and what does it do and what it comes to solve. And basically, in the past, I think 10 years, infrastructure as code is the first infrastructure as code framework was born. AWS, I think in 2010, came out with CloudFormation. And basically what it does, it comes to help provision and manage infrastructure at large scale. So if we'll take a look about application back then, it was like simple application with, I don't know, one app server, maybe a load balancer, and just, a MySQL that the customer does some requests and gets some data, but it's very basic back then. And now with cloud and cloud native and a lot of services that you have in all the cloud providers, now application looks like the right side. You have like an S3 bucket and internet gateway and VPC and load balancers and EC2 instances and lambdas and whatnot. And it's hard to basically create those infrastructure and environment. If back then you would just spin up one VM and one MySQL, and that's it. Now you have to provision the entire application, and you want to manage that through automation. And that's why infrastructure as code was born and what is addressed to do. So that's a bit about the background. And going back to that, once you go to the cloud providers, in the old days, you had like a few clicks, and then you'll have your environment ready or your VM ready or whatnot. But now AWS has like, I don't know, 10,000 services right now, and managing each service by clicking and creating it on the web console is not scalable. You cannot do that anymore. And then you'll basically have more than one environment, right? You have like at least dev environment, staging environment, production environment. So each time you want to change something or add a resource or do anything with your infrastructure, you need to do that at least 3 times, in dev and staging, and then repeat that in production. So I'm not talking about multiple environment. I'm talking like the basic stuff, dev, staging, and production. And now that you have like an application that has like tons of resources, you won't be able to do that manually anymore. So infrastructure as code came and said, okay, let's do that with code. Why code is so good to manage that? Well, basically, you can codify that and run it, and then you can basically create environment from scratch. You can destroy environment and the entire environment. You can update an environment, an existing environment. If you have like a lot of resources and you want to just change one piece of the infrastructure, you just codify it, run it against dev stage in production automatically, and boom, you have like everything set up with automation through code. And again, code has a lot of other benefits to it, like basically you have like the history of commits and see what you changed and who changed it and why he changed it. And you can do merge requests or pull requests on them and see and go through a workflow of approval. And there's a lot of other advantages of doing that, you know, with code and not with like a wiki that somebody says, okay, you need to go there and press on that service and change that that name of the service or create a new one. So everything is going to be in code in the upcoming years. That's for sure. Another reason that infrastructure as code became so massive is microservices. So basically, and cloud native. So back then you have like one monolith. Now you have microservices, and each service is, you know, it exists on its own. And going to cloud native, you're using a lot of the services that all the cloud provider offer you, and you have to manage that. And in large scale applications, you cannot manage that manually anymore. So welcome to the new age. DevOps teams now need to run infrastructure and deploy that to the cloud. But now, how do they do that? So, you know, you have like all the Git providers, you know, GitHub, Bitbucket, whatever. We're focusing on GitLab, of course. And you need to take that code and run it and ship that infrastructure on your cloud provider. If it's AWS, GCP, Azure, even VMware or Ali Cloud, IBM Cloud, whatever. So how do you do that? How do you manage that? How do you collaborate on that? Because, you know, once you have like a big team of DevOps engineers, you don't want to block anybody. It's just like code, you know, somebody wants to write a feature, you don't block them because someone else wants to write a feature. Same goes out here, you know, if you want somebody to write a code on a specific service or in a specific infrastructure, you don't want to block the other guy, and you want to manage that in that term. And I think we can correlate that to exactly what happened to Git before there were GitLabs. So, you know, back in the old day, there's like only Git. So you can collaborate on the code itself, but you don't have like the management on top of it to tell you, okay, you can collaborate on merge requests, you can collaborate on the diffs, you can do role-based access and see who does what and where. You have like the history and the UI to manage that. So in that term, infrastructure as code now gets into the phase that you need management tools, exactly like Git used to not have back in the days before there were the Git providers. Cool. So infrastructure as code, as I mentioned, been around for, I think, 10 years, 2010. AWS came up with the CloudFormation, and followed by a lot of things. So we have here Azure ARM templates. So basically, this is Azure specific, like CloudFormation is AWS specific. And then came all the cloud agnostic things. So in 2014, an open source called Terraform from HashiCorp was emerged, and he said, okay, you cannot go and do just one cloud because it doesn't scale. And if you're going into a multi-cloud approach, you cannot use CloudFormation or ARM template. And of course, you want to use just one tool to do the entire thing. And they came up with a new language. They call it HCL, a HashiCorp configuration language, and build Terraform on top of it. And Terraform works in a way that, so basically you have the core open source that runs Terraform and knows how to run and manage the run itself. And then on top of it, you have all the providers. So for example, AWS has a Terraform provider. GCP has a Terraform provider. Azure does, and basically GitLab has, and GitHub does, and everybody does. Also, all the third parties and SaaS applications as well, you can configure them using using Terraform. So exactly, I don't know, Auth0, SendGrid, New Relic, all have providers that you can configure your third-party SaaS application as well with Terraform. Just to mention, N0 as well has a Terraform provider, and basically we have like customer that write in Terraform code to configure N0, and they run it within N0, which is kind of cool. So this is Terraform, and it's been out there for the past 7 years, and it's been gaining a lot of momentum because it was cloud agnostic, because of the way that it was built and the way you can basically extend it with all those providers. And now everybody has a Terraform provider, because if you don't, your DevOps engineers wouldn't want to work with you anymore. So this is Terraform. There are two other logos here. One is TerraGrant, which is on the top right-hand side. TerraGrant is basically a framework that is on top of Terraform, and it gives you the ability to dry out your Terraform code and gives you more ability on how to manage environment, but still it's a CLI tool. It's a great open source, very popular. It has like, I don't know, 5,000 stars, and it's quite popular, but it's on top of Terraform. So you have to write your Terraform code if you want to use TerraGrant. Then came Pulumi. So all of those infrastructure as code were basically based on JSON or YAML or HCL, which is a declarative languages, which is good and nice and great, but you will have to learn a new language. So if it's CloudFormation, it's either JSON and YAMLs, and they have a lot of limitations. You cannot do for or loops, and ifs is quite hard with JSON or YAMLs. So all of those are basically declarative languages. And then came Pulumi, I think it was 2018 or 17, and said, okay, that's not good enough, and we want to build a different infrastructure as code tool that is based on basically languages like .NET or Python or Node.js or Go. And basically then you will be able to do all those cool things that you can do with basic code, with these ifs and loops, and you can do that with your specific language. So if you're a Python developer, it's easy for you to get started. And it's gaining a lot of momentum. Pulumi is quite gaining a lot of momentum in that space. But again, if we take the comparative to Terraform, it's younger and it has less support currently, but they took a bit of a different approach on how to solve the infrastructure as code problem. So that's an overview on the infrastructure as code platform or frameworks that we have. There are more like serverless.com or Kubernetes. Basically, it's an infrastructure as code as well, or Helm charts. But those are mainly around infrastructure, less around like serverless or specific like Kubernetes. So that's like an overview of the tools that we have. And basically, from all of those, Terraform is exploding. And the vast majority of the companies today in the world basically are using Terraform. You can see here, Ansible has been, it's a different tool. It's a configuration management. It's not infrastructure as code, but Terraform is gaining momentum, and basically I think this year will take over Ansible in terms of adoption. You can see the star of Terraform gaining huge momentum compared to Pulumi and TerraGrant, and the contributors as well. Actually, HashiCorp just issued a message that they are not accepting any community pull requests on Terraform on the open source itself, because they are lacking in staff, and they can handle basically the load that they have, and it's basically currently the go-to infrastructure as code framework for most of the companies, for sure. It's an open source, it's multi-cloud, it's the ecosystem that they have for providers. They have, I think, over 500 providers, I think over 5,000 models, and they have so many integration with so many platforms, and basically it's the leading framework of that space. Great. Well, infrastructure as code is great. And as we said before, now we need to do something about it. You need to write the code, and then you need to do something about it. So I'm going to dive into what GitLab does with Terraform. And later on the live demo, I'll show a bit of what you guys do with that. And basically, what it does is basically give you the ability to run deployments through the GitLab CI/CD platform. There's like specific images and CIs that you can run with Terraform that I'll show you later in my demo. Remote state management. So Terraform basically, in order to save the state of the resources that he created, he saves a JSON file, and this JSON file can be stored in various places. It can be locally if you're just doing something locally in your laptop, but it can be an S3 bucket or a Google storage or Azure Blob Storage, or there's Vault and other databases like etcd and others. And another thing that Terraform has is a remote state that you can basically implement the API, and then you have like a remote state based on HTTP. So what GitLab did is create a remote state management for Terraform based on HTTP. And if you're running your Terraform deployment through the GitLab CI/CD, it will automatically save the remote state if you configure it and like in the right way. It will save the remote state in GitLab, and you'll have like a UI to see the versions and the history and whatnot, which is great. You don't have to play with authentication and managing that, because it sometimes can be a bit of a pain. So that's another thing that GitLab does. Another thing is private model registry. So basically, as I mentioned, Terraform is based on two things. One is the providers. So as I mentioned, each cloud provider has its own Terraform provider, but there's also a way to basically do packaging of basically models. That's how they call it in Terraform. And there's two ways to do that. You can create a model which is an open source. So for example, if I'll go to AWS, I can use a model for their Kubernetes EKS solution or their S3 bucket. So there's tons of open source models for each resource. But then if you want to basically create a model which is not an open source, you need a registry to store it in, and basically give the access only to your organization, which is what is called a private model registry. So basically you write the code within your Git repository and then store it within a model registry. And then everybody in your organization can consume it with their Terraform code. So for example, if I have like a way that I want to strict how you create an S3 bucket because I want to do some configuration which is baked in only to my organization, I will create like a model registry, a private one for this S3 bucket, and everybody in the organization will have to use that model, which is very handy once you have like a big engineering or a DevOps team that want to collaborate on a lot of models and a lot of services. The last thing is merge request integration. So basically, Terraform has a way to let you know what it's going to do. So basically, it's called the Terraform plan. Terraform has a workflow where you have to run Terraform init to init Terraform. What it does is basically pull down all the providers' code into your local machine. Then you do a Terraform plan, which basically takes your Terraform code, understand what it needs to create, what it needs to delete, and what it needs to update. And then it gives you like a list of what it's going to do, which resources is going to create and delete and update. And then you can create an approval flow where somebody creates a plan and somebody else needs to go and take a look at it and then approve it. So what GitLab does with merge requests, so every time you have like a merge request, eventually you can do a plan on those changes against a real live environment and then get those changes or that plan into your merge request. And I'll show it later on the live demo and how it will help like another team member that is going to review it or the team member that is making the changes. Basically, it's kind of a CI on infrastructure. You create a merge request, you push a new code, and you get the plan according to a live environment. So you can basically know exactly how your code changes will change the live environment. So basically, that's what GitLab does with Terraform, and we'll check it out a bit later. I'll show you in the live demo. Cool. So now we're done with infrastructure as code. Let's go back to the cloud provider and talk about tagging and labeling. So tagging is mainly to AWS and Azure. That's how they call it. With GCP, it's labeling, and our live demo will be on GCP, so it's labeling, but it's basically the same thing. So all major cloud provider allowed you to tag or label your cloud resources. They encourage you to do so because it gives you a lot of ways and powerful things on top of that. One thing is budget, automation, insight you can create with those labels. And basically it gives you the ability to, from the cloud provider, get insight on the specific resources. And infrastructure store tools like Terraform, basically on every resource that is taggable, you can use Terraform to do so. So basically you need to go into your Terraform code and basically add a section which is the label or the tag. So it gives you like the ability to track down resources, both in the development, the ops, the business side, and whatnot, which is great. But there's a lot of things that you need to pay attention, because basically it's hard to maintain standards once you have like a huge DevOps team, or even developers usually also starting to write Terraform code. You need to enforce some kind of strategy on how you label or tag your resources. And it's becoming harder as your code base grows. And applying those changes, if unmanageable, it's quite hard. And if you already have like resources already in your cloud providers, now you want to tag them, you need to go back to your code and then run through all the taggable resources and put code inside of them. So it's a hard thing to do. And another thing I've talked about models. So if you're using like a third-party model that doesn't give you the ability to tag, you're in a trouble, because you're using an open source that might or may not give you the ability to tag the resources that he's creating. So it's a big issue, and tagging and labeling overall in the cloud is a huge deal when it comes to DevOps engineers, and basically not only, also for managing resources and managing budgets. All cloud providers are basically relying on resources to get this done, and I'll show you how GCP does that as well. Which is great, and that's why Terratag came to the rescue. I think about a year and a half ago, we said, okay, that this is a problem. We feel the problem internally, and we saw customers struggling with that, and we said, okay, what can we do to solve that problem? And basically, it came out of a feature that we wanted to create on the Entire platform. And we said, okay, this is great. Let's open source it as well. So Terratag is an open source. It's a CLI tool that basically gives you the ability to automatically tag all the resources in your Terraform code. It doesn't matter if you have like models inside that code, if it's your code, if it's a private model or whatever. It basically gives you the ability to tag all those resources. Even if it's not your Terraform code, if you're using like a third party or open source model. It works with all the major cloud providers like AWS, GCP, and Azure, and we have like customers using that for all of them, all of those. And once you go to a multi-cloud approach, it's kind of hard doing that with one tool, which is great. So it solves the complicated problem of tagging across application at scale. Once you have a large application with a lot of resources, it's becoming a big problem, and it eliminates the human error. Basically, you do that automatically, and you can stuck it in your CI/CD pipeline and forget about it, basically. And gives you the ability to do cost management, organization, reporting, and what tagging and labeling gives you on top of that. Cool, so let's go to a live demo. I'll show you, based on the blog post, exactly what I did. It's on a repository. This is the repository in GitLab. It's open source, so you can check it out. There's links in the blog post as well. And let's go a bit about the structure. It's a really simple one. Let's go first and check out the Terraform code. So the Terraform code is basically, this is what HCL looks like. You can see there's a section called Terraform, and this is where I configure two things. One is the providers that I need. So in this case, I'm going to use Google, which is an official Google provider from HashiCorp. And I need to state what version do I need. And another thing is the backend. So I need to specify where do I want to save my states. And as I mentioned before, I'm going to use GitLab to save my states. So all I have to do is basically do this and specify its HTTP. And because I run this inside of GitLab CI/CD, it will automatically save the states within GitHub, and I don't need to specify any authentication at all. Great, so let's take a look at some of the things that I need to configure. So I need to configure Google, and I need to set the project ID that I'm going to use, and also the region and the zone and basically that's it. I'll show you later on how authentication is going to be done. And here I'm going to create two resources. One is a VM instance with a disk. And another thing that because I'm going to initiate a VM, I need a VPC and a network. So it's going to create basically a VPC inside of Google, which is kind of straightforward. Let's go take a look at the variables. So there's another file that basically states what of the variables that I need in order to run this Terraform code. So I need the project ID. I need what machine type do I want to initiate, which region with a default to this region, and which zone with a default to this zone. So basically defaults means that I don't have to specify it, and if I don't specify it, it will take this default. Good, very easy, but then I want to run it. So I'm going to use GitLab CI. So I have like the YAML file right here. And it's based on the image that is under the registry of GitLab, which is the Terraform image. And I configure a lot of stuff here, but let's take a look a bit about the stages that I have. Okay, so I have two stages. I wanted to show you a use case where I do a plan, and then somebody can check the plan and approve it, and then somebody else will need to run manually the apply. So the plan stage is basically I download Terratag from the Terratag repository, and then I do a Terraform init, and then Terraform validate. Validate basically verifies that the code that I wrote, the Terraform code that I wrote, is valid. It's kind of a compiling error and checking out that everything is okay. And then I run Terratag. Basically what I do with Terratag is I give them the TF folder, so where the Terraform folders and the Terraform files lives. And then I give it the tags. So I want to specify which tags I want to insert to all of the resources that I'm going to create from this Terraform code. In this case, I gave it like an environment name and call it Terratag blog post. But I can, do whatever I want to, and I can have as many tags as I want to. I'm saving the artifacts because the way Terraform works, you can save the plan to a file, and then when you apply it, you can apply it on that file. So basically it takes the plan and execute it. And in this case, because it's a two-step deployment, I need to save the plan file somewhere. So I'm using like GitLab artifacts to save it. And then in the apply, I'm basically getting the artifact as a dependency from the plan. Cool, quite simple. So let's go ahead and try to deploy it. There are two things that I wanted to say before I run this pipeline. So authentication, I'm using basically the variables that lives inside of GitLab. So I need to give it authentication to Google and the project ID and the instance type. So all of that was done under settings in general, and I configured the environment variable. You can actually configure variables as well here, but I already did it because it's sensitive data, so I didn't want to do it here. So let's run the pipeline on the main branch and see what happens. And if I'll go, you see there's two steps. One is the plan, and the other one is the apply. And once the plan will be done, basically it will give me the entire what Terraform is going to execute and which resources are going to be created. That way, every time I do something, I can basically go ahead and check the plan and see if it fits what I wanted to do. So this is the plan. So we can see that it's going to create a Google computer instance, and the name of the resource is VM instance and all of those things. And here you can see I didn't specify any labels, if you remember from the code, but Terratag inserted the label as I wanted to, as an environment name and the environment name value as well. And it did that automatically without any code change. And think if you have like a large application with a lot of resources and a huge code base, this will be done automatically for you, which is kind of cool and kind of great. You don't have to worry about that. Just stick it in your CI/CD pipeline, and basically that's it. And you can basically monitor it and see and create standards for it. And it's really great to see that in action. So let's go back to the pipeline, and I will be able to see you have a small bug there in refresh, but I can see the plan is done, and basically I can hit apply and it will create the resources in GCP. I won't do that because I already have like the resources in GCP, but let's go and see what does it mean in Google Cloud to have those tags. So I'm gonna focus on cost because it's like the biggest issue with tags and labels. And here is the report of N0 GCP. We're not based on GCP, it's just some stuff that we run there. And you can see the cost is in shekels because we're in Israel. And then I want to see, okay, this is the entire project billing. I don't want that. I want just to take a look at my environment. So basically here I can basically say, okay, I want to filter by a label. And you can see that that's the label, environment name. And then I have 3 values. So let's take out production because I don't want to deal with production. I don't want to deal with GitHub because they're not interested anymore. And here I can see a graph that tells me exactly how much that environment and those resources cost me. And then you can do that based on teams, based on users, based on services, and really take a great BI tool like Google Reports on the billing side and take it to another level with all those filters on labels. Cool, so that's GitLab and how it uses it. I wanted to show you that under infrastructure, you have also Terraform. And under Terraform, I can see the states of this. Basically, I have one state here, but I can download the JSON. I can lock the state so nobody else can access it. I can do a lot of stuff on that, but have visibility on which states do I have under this repository. Cool, so that's great. I want to show you another thing, and this is how N0 integrates with GitLab. So what we do beside of, so basically N0 is a platform that manages all of those cloud deployments and give you a way to manage all those environments in an easy and self-service way. But then we want to integrate with the pipelines that DevOps basically they love and nurture, which is basically writing code and doing merge requests. And here I have like a repository that I've created a merge request, and I changed some code like infrastructure's code. And now I have a comment on this pull request saying, okay, your code changes will basically add a new resources. It won't change any resource and it won't destroy any resource. But if you want to see, this is the plan that we saw earlier, and now it's on the merge request. And this is quite cool because every time I push a new code, I will able to see exactly what will change on an actual environment. And this is kind of the CI of continuous integration on top of infrastructure as code. Another thing that we do is basically give you a cost estimation that telling you, okay, those changes that you've made are going to cost you X amount of dollars. And we can show you the diff from the last deployment that you've made, and also the total of how much this environment will cost. In this case, it does nothing, so it doesn't cost me anything. It's actually not going to create any resource on cloud provider, but basically this will also get you the ability to get value in terms of your code and how will it affect the cost of those environments and those cloud resources. And basically we have like links back to M0 platform if you want to take a deeper look on the environment and the states and what exactly is going on there directly from your pull request. And this comment will be updated based on each push you will make. So here I can see like the exact deployment and who did it, and a link back to the PR and how much time does this cost and where does it started and from which template and which revision, and go through all the logs that basically were there. And I have like the cost estimation, and I see the environment, and it gives me a better overview of the entire environment that I currently have under that project in the M0 platform. Cool. So basically that's it in terms of the live demo. I hope you got it. So we took a look at M0 and how it integrates with GitLab using the template creation and pulling Terraform code, the merge request, the cost estimation of merge request, and we actually also have a private model registry. That's it. There's other notable open source for infrastructure as code that you can check out, like Chekhov, which is on the security side, Infracost, which is on the cost side, and Terrascan, which is also in the security. And there's Atlantis, that is basically automation on top of a pull request for Terraform. So you can go and check it out. I guess that's it. And now Q&A.
So thank you so much for the time in the presentation. Right before we do Q&A, I don't see any questions in the notes document, so we've got an open floor, but I want to launch a quick poll for the audience here about your familiarity with Terraform and infrastructure as code. So I just launched that poll. We appreciate your responses. And do we have any questions for our guest? I don't have anything in the notes document.
So it's either I'm very good or I'm lousy presentation.
Simon says, thank you for the presentation.
Yeah, so I just wrote it into the doc. I'll verbalize it here. It's Edmund. What is the commercial opportunity for ENVs in working with GitLab?
So basically, we have a lot of customers that are using GitLab. Basically, their Terraform code is based in GitLab. We also have an offering for GitLab.com and GitLab Enterprise, and we have a few customers on both sides. So our offering is basically integrated with GitLab and the merge request. We don't have partnership with GitLab yet, but we might have in the future. But it's a separate tool than GitLab. So our focus is on managing the deployments and the environments in a high level, and giving the DevOps the ability to create kind of guardrails on top of their deployments and creating a self-service management platform for everybody that needs the environment. If it's a DevOps, a developer, a QA, and automation, or even sales engineers or salespeople that needs like environment for POC, and giving them the ability to manage that, both in terms of basically an easy tool to spin up new environments, both in terms of guardrails that you can apply on those deployments, both in terms of cost. We can give you, using Terratag, basically give you exactly how much an environment costs you. So we have like basically we pull out from the cloud provider how much a specific environment costs you, exactly like you saw in GCP. We can do that also if you're multi-cloud, and gives you basically also the cost over time and correlation to the deployment. So you can see like bad deployments that cost you a lot, and the cost estimation side. So we are a platform which is focused on doing that. And the integration with GitHub is based on the merge request. Like you said, like you saw, the cost estimation, private model registry, and supporting both GitLab.com and the enterprise version.
Okay, so if I can just summarize from enriching what we do with Terraform already, Terratag is wonderful in being able to label or tag the resources being created. The added value that your organization can can provide is around valuing the changes that are being made and help organizations understand the costs that are involved in making those deployments or changes, and also comparing costs between different cloud providers.
Yeah, exactly. Yeah.
Okay.
And another thing that we do is basically CI/CD based on GitLab events. So every time you create a pull request or do a push, we automatically can deploy the environment or create a merge request comment on the merge request.
And what is the cost of your product?
Oh, okay. So we have like a pricing page, and it depends on the basically we have a free tier. We have like a SaaS offering, which is based on either users or environments, and it's $20 per user or environment, depending on which tier you want to go. And then we have like a self-hosted agents, which basically gives you the ability to run the Terraform code within your cloud applications or cloud provider, which goes higher in the spectrum of the price range. And then we have like the enterprise version as well. So it varies. I think an average customer right now is, I think, around $1,000 a month. That's like the average price range right now, where the big enterprise, pay a bit more because they consume more deployments and more of the usage, and has a lot of more people on the platform. So basically, a lot of customers have a lot of developers on the platform for creating ephemeral environment for their feature branch, and then the price goes higher and higher.
Understood. Thank you.
All right, we just got a few more minutes here. Don't see any other questions in the document. Any other questions or comments for our guests? All right, well, I think that's all. So I want to thank you again so much for joining us. Thank you, Itzik. Thank you, Omri. I hope everybody has a fantastic day, and we will see you again in 2 weeks.
Thank you very much, and thank you for having me. It's been a pleasure.
Thank you, Omri.
Thank you.
The pleasure is ours. Thank you. Goodbye, everybody.
Bye, guys.
All right, see ya.